Today we are doing 13.2, which is slope of a line. The majority of 13.2 is really a review of when we did slope earlier in the year. And then at the end, we're going to add on what is actually the 13.2 extension, which looks at parallel and perpendicular lines and how that has to do with slope. So our first key idea here should be a review for you. The slope of a line is the ratio of change in y, which we call rise, to the change of x, the run. So we talked about slope being rise over run, that ratio. And then we also talked about how we can use the formula to help us find it between points. So you can graph it and you can actually count the rise, how far up and down, the run, how far side to side. And then you could also take your values and subtract your y values and subtract your x values and write your ratio that way. And of course, just like any other ratio or fraction that we've done, if we can simplify it, we do want to make sure that it's in simplest form. For slope, you are going to have a fraction or a whole number. You will not have a mixed number unless you have some sort of story problem situation. So we need to see those two different parts, the rise and the run, even if it looks like an improper fraction. We have two different examples of slope here. So positive slope from left to right looks like it's going up. Negative slope from left to right looks like it is going down. Remember, with negative slope, you can add in some lines to the side and you'll see a capital N if it's negative slope. So that's negative slope. Negative slope can make that capital N. The line looks like it's going down as you're looking at it from left to right. All right, so let's take a look at some slope problems. First type of problem just asks you to look at a picture and describe the slope, whether it's positive or negative, and then you actually find it. So our line A from left to right is going up, so that's going to be a positive slope. And then we count the rise over the run. They have the rise marked in red for us here. That's 5. It's going up 5. And then for the run, it's going over 6. So up 5 over 6. When we did this earlier in the year, I generally like to make my steps on the top. So you can see your rise first and then your run, but it doesn't really matter. The book, for whatever reason, put the slope underneath the line instead of on top of it, but it gives you the same answer either way. So up 5 over 6, that can't simplify, so that is my slope. B, the line is pointing down, which means we have a negative slope, and that means our number needs a negative sign in front of it. This is negative because our rise is actually going down. If you make a step here, you're going down 3 and you're going over 2. So our rise is negative 3, our run is 2. So our slope is negative and it's negative 3/2. Okay, so we have 3 graphs here. Go ahead and pause the video and find the slope of all 3 lines. All right, let's check to see if your answers are correct. So I've drawn in my little steps here. Number 1 is a negative slope, and you should have negative 1/5. That as we went from the first point to the second, we went down 1, and then we went to the right 5. For 2, that is a positive slope, and it is a positive 1/3 when you simplify it. So I didn't draw it out here. I certainly can. So when I originally counted it, I went up 2 and over 6, but that simplifies to 1/3. And then for our last one here, that is a positive 5/2. Again, you have to count your rise first. So that's going up 5 and then going over 2. So 5 over 2. And again, we don't want to make that into a mixed number unless it's a story problem situation where a mixed number stands for a certain thing. All right, so there are 2 other types of slope that we haven't seen yet today, and that's undefined and 0. So we have a couple different ways to remember it. Undefined, if you think when I'm subtracting and I have 0 on the bottom, that's not allowed. You can't divide by 0, so no, if it's 0 on the bottom, no, it doesn't work. That gives you an undefined line. It's going to look like this, a vertical line up and down. If you have 0 on the top, that's okay. You can take 0 and divide it into two groups, it's still 0. But you can't take two things and divide it into 0 groups. So 0 on the bottom, no, it's undefined. 0 on the top, yep, that's okay. That's going to give you a slope of 0, and it's going to look like this, a horizontal line. So 0 divided by 7, that gives you a slope of 0. The other way to do it is you can think about how you can change this vertical line and the horizontal line into the letters U for undefined and Z for 0. So for this one, I could take that line there, make it my U for undefined, and my horizontal line I could take and change into a Z for 0 slope. So for this particular slope, we have the slope of 0 because it's a little hard to see. I'm going to redraw it for you. But we have a horizontal line. We went over 7 and we didn't go up at all. So rise was 0, or run was 7. That gives us a 0 slope. We don't even really need to write the 0 over 7. If we see it's a horizontal line, it is going to have a slope of 0. All right, on this next one, here's an example of an undefined line. Again, the line's a little hard to see, so I'll outline it here. But it is a vertical line going through the points 4, 6, and 4, 2. So our rise is 4. We went up 4 units from the first point to the second point. But our run is 0. We didn't change horizontally, so that's going to be an undefined slope. Now, on these next ones for you to try, they did not give you the picture. So you can do the picture, or you can use our slope formula, which I put in there next to problem number 4, just to remind you of what that formula looks like. So you can subtract your y's and subtract your x's, and that's another way of finding slope. So if I'm going to call this my first one, and I'm going to call this one my second one. If I subtract my y's or my second values, so it's like -2 minus the -2 from the other point. Actually, I said this was my second one. So -2 for the first, -2 for the other one. And if I do boom, boom, think about what you're going to get on the top. I'm not going to solve it all the way for you guys. And for the second one, for my x's, 0.2 was 7, and 0.1 was 1. So go ahead, you can finish, or you should finish this problem. So you can go ahead and calculate -2 plus +2, write down what you get. 7 minus 1, write down what you get, and then you're going to end up with something that's either a 0 or an undefined slope for all of these problems. So go ahead, take a minute, pause the video, and find the slope for these next problems. Okay, let's go ahead and check our answers. All right, so for this one here, you can see I actually wrote in x1 and y1, x2, y2. When you subtract, you get 0 over 6. That simplifies to 0. For number 5, when you subtract, your y's are the same. That's going to end up giving you 0 on the top, 0 slope. On number 6, if you notice, our x values are the ones that are the same there. When we do the subtraction, we get -2 on the top and we get 0 on the bottom. 0 on the bottom means it's undefined. Number 7, same thing. Our x's are the ones that are the same. We do 8 minus 0 on the top. I could have done 0 minus 8. It really doesn't matter which point you pick to start with. I did 8 minus 0. And then 0 minus 0. So I get 8 over 0. 0 is on the bottom, so it's going to be undefined. And then our last question down here, how do you know the slope of every horizontal line is 0, and how do you know the slope of every vertical line is undefined? So horizontal, there's no rise at all. It's flat like the floor. So 0 is going to be on the top part of my ratio, and it will be 0 overall. Vertical, no run. It doesn't go side to side. It only goes straight up and down. We have a 0 on the bottom, and you can't divide by 0, so that's going to make it undefined. Okay, on this next type of problem, they're not giving you a graph for slope, they're giving you a table, and they want you to use the slope formula to solve for the slope on the table. So you can pick any 2 points that you want to on the table to use your slope formula for. I chose the first 2 points. So the first point there is 1, 8, and the second point is 4, 6. So this 1 over 8 became my 1, 8 here, and the 4 over 6 became 4, 6 here. And then you need to set up your subtraction. Remember, your y's are going to go on the top because that represents our rise. So I chose the second point to write first. The 6 went on the top, the 4 went on the bottom. And then I subtracted the numbers from my first point. So the 8 goes on the top, that's the y value. 1 goes on the bottom, and then when I subtract, I have 6 minus 8 is -2, and 4 minus 1 is 3. If I had subtracted in the other order, I would have gotten a +2 on the top and the -3 on the bottom. It doesn't really matter, but our slope for that one is going to be -2/3. So here are 2 more for you to try on your own. Go ahead and pause the video and find the slope for these 2. Okay, let's check your answers. So on both of these, I chose the first 2 points. Again, you could pick any 2 that you want to. So for number 9, my y values are the ones on the bottom here, and I started with the numbers in the second column first. So my y's were 5 and 2, 5 minus 2, and my x's were the 3 and 1, 3 minus 1. When I subtract, I get 3 halves. Again, slope we don't make into mixed numbers, only whole numbers or fractions that are in simplest form. And then number 10, I did the same thing on the top. You have to put the y's on the top. I chose to do the second column first. So I did 4 minus 6, that's -2. That's the top part of my ratio. And then I did -2 minus 3. I did do boom, boom, made it plus +3. -2 plus +3 is 1. And then I simplified. -2 over 1 simplifies to -2. You can have a whole number or an integer as your slope for a line. Okay, and then this is kind of the wrap up for the first part, the 3.2 slope part of our video. For each one, they're asking you to label the graph with the type of slope, positive, negative, 0, undefined. Go ahead and take a moment to pause the video and try this. All right, let's go ahead and check to see if your answers are correct. The first one is positive, line rises from left to right. Second one is negative. We can change that into the same slant of an capital N. 0 is our horizontal one, and our last one, up and down, is undefined. So now we're going to move on into the 3.2 extension. This is new information. It's really an application of slope. So for parallel lines extend forever and do not intersect. So if we have parallel lines, they have the same slope. Now on the key idea here, it says non-vertical parallel lines. That's because vertical lines have undefined slope. That isn't really a slope. It's just what we write for it. But vertical lines, of course, are going to be parallel as well. So here we have 2 different lines, and they actually give you the equations. Y equals 1/2 x plus 3. This one is y equals 1/2 x plus 1. And for each of them, if we found the slope, that would be the slope of up 1/2. Up 1 over 2 and up 1 over 2 works for both of those lines. They're parallel. They have the same slope. For those 2 lines, the slope is 1/2. All right, so for this problem, which 2 lines are parallel and how do you know? So the first step for us on this one is to go ahead and calculate the rise and run for each one of those individual lines. So here I've done that. I have, for the blue line, the slope is 4. For the red line, my slope is 5. And for the green line, my slope is 4. The first and last lines, the blue and the green, had the same slope. So those are the 2 that are parallel. Perpendicular is kind of the opposite there. So perpendicular lines are ones that intersect at right angles. And it says 2 non-vertical lines are perpendicular when the product of their slopes is -1. That's called the negative reciprocal. We talked about reciprocals when we did fraction division and we did keep, change, flip. And we said when we flip the fraction, that's the reciprocal. Same thing here, it's just that one of your numbers is going to be negative and one of them is going to be positive. If you have a vertical line and a horizontal line, those are also going to be perpendicular to each other. Again, they're not saying that the product equals -1 because one of those slopes is undefined and one of those slopes is 0. But if you have a vertical and horizontal line, those will be perpendicular as well. So for this one, which two lines are perpendicular and how do you know? You start by looking for some right angles. So if you kind of look at the picture, you might see where you think is a right angle and what you might not be a right angle, but it's a little hard to tell. So you do need to find the slope for each of those lines and then look to see which ones are negative reciprocals. They have the same numbers, but they're flipped, and one of them is positive and one of them is negative. So if you look at my work here, and I do have a lot of writing on there, for my blue line on the top, I went over 6, that's a slope of -1/3. For the red line, I went down 2 and then over 7, that's a slope of -2/7. And then for the green line up here, that's a slope of 7 over 2. It looks like that got erased off there. But if I count up and I go up and over, I go up 7 and then I go over 2. So from here all the way up, that's an increase of 7 and then over 2. So 7 over 2 is the green line. So the ones that are perpendicular, that's going to be these two that I've circled here, the red one and the green one, and that's because they are negative reciprocals. If I do 7/2 for the green line times -2/7 for the red line, that's going to give me a product of -1. And for our final problem here, you're going to take a moment and pause the video and you're going to answer this question: which lines are parallel, which lines are perpendicular, and how do you know? So go ahead, take a moment, pause the video, and then answer this question. Okay, let's go ahead and check our answer. So you needed to find the slope of all 4 lines there. When I did the slope of the red line, I got 1/3. When I found the slope of the blue line, it was 1/2. The slope of the green line is 1/3, and the slope of the black line is -2. So the ones parallel, these two lines that kind of look like an 11, that's the symbol for parallel, and that's the red and the green. They both have a slope of 1/3. The ones that are perpendicular, the sign for perpendicular kind of looks like an upside down T, capital T. Those are the blue and black lines. That's because 1/2 times -2 equals -1. And that's all we have for today.